Okay, so here we have our first classroom R example question I'll be going over on sampling and estimation. In this question, we're to create a population with a mean of 100 and a standard deviation of 20. And here we have the variable popn, and this arrow is just saying we're going to be putting whatever's to the right of it into that variable. So we're giving it random numbers are drawn from the normal distribution, taking 100,000 of them, and the population should have a mean of 100 and a standard deviation of 20, or around that. So one trick I use for Windows to run code is just holding Control and hitting Enter. It's easier than copying and clicking down here and pasting. And if you're Mac, I don't know what to say. You probably have something else similar to it. So next we want the mean and standard deviation of popn. That's generated, and we get 100 mean with standard deviation of 20, so very close to what we were looking for, but we do have a very, very large sample, so likelihood we'll get values close to that is really high. So now it wants us to take a sample from this population with the size n equals 5. And for fun, we want to imagine that they were IQ trained and see if their IQs are significantly higher than the general population. So S1 sample 1 will be assigned a sample from popn that's size 5. So run that, and let's just see what is in S1 by typing S1. Here's our 5 numbers. This one has a mean of 100 and a standard deviation of 18. Not really interesting. Let's do it again. Okay, here we go. So now we want to determine the probability of obtaining a mean IQ higher than this of the sample mean. So what's likelihood we would have got a sample as big or larger than this? And just a reminder, before it was 100, so now we're putting into a variable we're creating called z, the mean of S1, subtract the mean of popn, divided by the standard deviation of popn divided by the square root of length S1. And all length S1 is just how many numbers we have stored in S1. And what you can see is quite simply 5. So the z we get for this is 1.47, and calculate the probability of this number in a normally distributed curve of scores using that particular z. Probability of getting a sample mean greater than this number is 0.07. So it's very unlikely that you would get a sample mean larger than 123 drawn from that population. And that should be all for this first example question.